In this section, we dive into the important and practical topic of synchronizing variables over the network using RPC calls. So we're heading over to scene 1, then we select Gameplay Manager and create a new script with the same title and add it. Now we open this script in Visual Studio. Here we create an instance of this script so we can easily access all the public variables and methods. Next, we have the variables player count, enemy count, current emerald, and max emerald. And all of these are going to be synced in the gameplay for all players. We define the variable enemy spawn seed, which changes according to the number of players in the game. The variable emerald spawn percentage shows the spawn rate of emerald in the game. We select these two and place them farther down. For these fields, we use the space attribute, which creates some spacing between the upper and lower fields. This script is supposed to run only on the master client. So we need to add this if statement at the start of the start method. Define the photon view variable used in the if statement here, and then we reference it in await. In the start method, we create and call game criteria coroutine, which sets the initial values of some gameplay fields based on the players present in the room. In this coroutine, we call and define the game criteria method, which initializes the values of the fields for us. So in here, by using the find objects of type method, we can find all the objects that have the player controller script attached. If you notice, by hovering over the method name, you'll see that this function has been deprecated in Unity version 6. So we need to replace it with the find objects by type method. For the input parameter, we'll choose the value of find objects sort mode.none. And then we'll store the number of players in the player count variable. Now we know that how many players are in the game. We need to adjust the game roles based on that number. We add the player count to enemy spawn seed. We double the player count and add it to max emerald. And we multiply the emerald spawn percentage by emerald count to set the spawn rate of emeralds in the game. Next, we go back to Unity and add the Photon View component to the Gameplay Manager object. For the view ID, we set it to 500, but you can choose any other value. The reason we assign 500 or any other value to this object is to avoid conflicts with objects that are spawned in the scene which dynamically get assigned a view ID. Go to Sample Scene and select Build and Run. In this run, We decide to consider the editor as the master client, so we click create room to create a room and continue with the process. Now if we select the gameplay manager object, you'll see that the values of max emerald, enemy spawn seed, and emerald spawn percentage change on the master client according to the number of players in the game. Up to this point, the game criteria method in the gameplay manager script is working correctly. Now we stop the game and check the second case where the editor acts as a client. So we click build and run again. So here we click create room and create a new room. Now if we select the gameplay manager again, you'll notice that the changes we saw in the previous case for the fields are not present here. We want the changes made on the master client to be reflected here as well. The solution to this problem is to sync the variables we need across the network. We achieve this by using RPC calls. So next we want to sync these fields across the network. So the changes made on the master client are also reflected on the client, and we can modify some of the values. Now we stop the game and go to the gameplay manager script. To sync these variables across the network, we define a method called syncValues here and specifying all the variables that need to be synced as input arguments and assigning values to them as shown. Don't forget to add the PUN RPC attribute as well. We place this method exactly at the end of the code for the game criteria function, and then we call it. After saving the script, we go back to Unity and test the game again in different modes. You'll notice that, just like before when the editor was acting as the master client, the script works correctly here as well, and there are no issues. Now we stop the game and test the next case where the editor is considered as the client. Now, we expand Scene 1 and select the Gameplay Manager object. As you can see, in this case as well, the variable syncing across the network is working correctly, and there are no issues anymore. So every time you want to sync variables across the network in Photon, you can follow the method explained here and use RPC calls.